Let's look at the fructose metabolism and the last minor metabolic pathway which we are going to learn. So this is the basic of fructose metabolism. So fructose, with the help of fructokinase, can be converted into fructose 1-phosphate. Now aldolase B will break down this fructose 1-phosphate into dihydroxyacetone phosphate and glyceraldehyde. Then again phosphorylation will convert it to glycerol 3-phosphate, which can go into glycolysis. Imagine if this is absent, fructokinase is absent. Still, this fructose can be converted into fructose 6-phosphate with the help of hexokinase, and this fructose 6-phosphate will be converted into fructose 1,6-biphosphate with the help of phosphofructokinase, and again it will be broken down into glycerol 3-phosphate and go into glycolysis. So fructose can go into both the pathways. So what are the deficiency and what are the diseases associated? So remember, imagine if this fructokinase is absent. So then what will happen? Will fructose be accumulating? Yes, fructose will be accumulating, but the accumulation will not be very high because some amount of fructose can go into this pathway. Okay, because hexokinase can also convert fructose into fructose 6-phosphate. Second, fructose accumulation causes fructose urea. So which means if there is an increased fructose level, our renal threshold of fructose is very low. So immediately that fructose will be excreted from urine. Our renal threshold for fructose is very low, which means, even there is a slight increase in the fructose level of the blood, the kidneys will throw away that fructose. That is why we have fructosuria. In case of galactose, I told you the renal threshold for galactose is very high. So if there is an increase in blood level of galactose, still the kidneys will not throw away the excess galactose. So there will be galactosemia, which means increase in the blood level of galactose. But whenever there is a fructose accumulation, it will not increase in the blood, it will be simply thrown out of our body. Okay. So this deficiency practically does not produce any disease. Okay. This deficiency does not produce any, because whatever fructose it will be metabolized or thrown away. But imagine if this aldolase B is absent. If this aldolase B is absent, then what will happen? This fructose 1-phosphate will accumulate. Okay, and this is very, very dangerous because first of all, you see all the phosphate is going to be chelated. All the fructose will chelate a phosphate. Second, so there is a chelation of phosphate. Okay. Second very important thing is that this fructose 1-phosphate inhibits glycogen phosphorylase, like galactose 1-phosphate also. Because it inhibits galactose 1 and glycogen phosphorylase, so there will be decrease in breakdown of glycogen. And the last, this is hepatotoxic. This fructose 1-phosphate is hepatotoxic. It cannot go into any other metabolic pathway. So all these things, this aldolase B is a very, very severe disease. Okay. And how does it present? Generally, children are not given fructose when they are born. So during the age of weaning, at around 4 months or 6 months, when fruit juices or foods containing fructose are introduced into the diet, then the children will have symptoms and very severe symptoms. Okay, let's look at the last and very, very important part about fructose metabolism. Now, when we see fructose is metabolized, which is the normal metabolic pathway of fructose, this fructose is quickly converted into glyceraldehyde 3-phosphate. Both these enzymes are very fast, they are not regulated. Okay, if you see on the contrary, if you see glucose has to be first converted into fructose 6-phosphate, this will have to be converted into fructose 1,6-biphosphate, and this is a very slow step. This is a highly regulated step. You remember, it's a very highly regulated step. So glucose conversion to glyceraldehyde 3-phosphate is a much slow, and fructose conversion into glyceraldehyde 3-phosphate is very fast. So fructose is a faster source of energy than glucose. Understood? Fructose is a faster source because these three reactions are not regulated at all. They immediately can happen. But when glucose is given, this step will be very highly regulated. So that is why whenever a patient is weak or sick, we give fruit juices and not glucose, because fruit juices provide immediate energy. Also, a person, if someone is weak, we give fruit juices because it is more lipogenic. It will generate more fat because immediately this fructose will be converted into this. It will go into glycolysis and it will form acetyl-CoA. Whereas this step is highly regulated in terms of glucose. So fructose is more lipogenic as compared to glucose. So any person who is weak or require quick energy, fructose is a better source than glucose. So this is the third point. Having learned about these points of fructose metabolism, let's quickly see some of the one-liners which have been asked on fructose metabolism. So remember, the first important thing is fructose undergoes more rapid glycolysis than liver. As I told you, it is bypassing the rate limiting step or the committed step or the most regulated step of glycolysis. Okay. One of the most common source of fructose is sucrose, okay, and fructose corn syrup. GLUT4 receptors are very important for the transport of fructose from intestinal lumen to the blood cells. And GLUT2 and GLUT5 both can, help fructose enter into the cell. Fructose entry into the cell is insulin independent, okay, and also fructose do not cause insulin release, okay. It is the major source of energy for sperms, okay, and fructose is considered to be the most lipogenic sugar, because again I told you all the other sugars will be converted into glucose and primarily take that pathway, but fructose immediately will be getting into glycosyl 3 phosphate, okay. Unlike glucokinase, fructokinase activity is not affected by insulin. Hence, in diabetes mellitus, fructose or fruit sugar, you know, fruits can be easily metabolized. Okay, in diabetes, fruits can be easily metabolized. So there are two diseases I have already talked about each one of them. First is hereditary fructose intolerance. So this is when your, aldolase B is absent, and early in life, soon after food or formula containing fructose sugar is introduced, okay, there is an acute fructose indigestion. So whenever the patient will take fructose, he will have, symptomatic hypoglycemia and so many other symptoms. And because this fructose 1 phosphate is, toxic, so it will lead to a lot of liver toxicity symptoms like clotting, time increase, hypoalbuminia, increase in bilirubin and transaminase level. Even it can cause proximal tubular dysfunction or, so this is basically hereditary fructose intolerance. So what is the mechanism? Again, I have told you fructose 1 phosphate is accumulating. So this will inhibit glycogenolysis. So there will be a decrease in glycogen breakdown. Also, there will be a sequestration of pi, which will lead to form of falling of ATP, and which will lead to lactic acidosis. AMP level, if it is lives increase, then there will be purine degradation and hyperuricemia. So all these are various symptoms of, aldolase B deficiency or, acute fructose intolerance. The second step, which is more of a benign step, is benign disease, is basically an essential fructosuria, okay, also called as benign fructosuria, because it does not have any, biochemical effect. Simply the fructose is thrown out of the body. So the fructokinase is defect. This gene, has been asked in the examination, chromosome 2p 23.3. How do we do it? How do we test it? So basically, these people generally present, during their adulthood, when they come for a normal routine check and you do a urine test and you find reducing sugars in their urine, but that reducing sugar is not glucose, so you realize that it is fructose. So that is how, and generally you don't have to do anything for these patients. There is no management for these patients, no dietary modification. The only thing you can say is not consume anything which is high in fructose, like fructose corn syrup. So that is all about fructose.